All right, section 2.2 in behavior. This is chapter 2's notes, pages 5 and 7. We are going to investigate the end behavior of a linear function and a quadratic function to help us learn how to classify end behavior. Notice the function y equals x, leading coefficient positive, exponent is 1, is odd. What happens? The left end is pointing down, so when I'm heading towards, x is heading towards negative infinity, y is heading towards negative infinity. When I'm moving right, that is, x is heading to positive infinity. My y's are going up, which would be going to positive infinity. What happens the other way when I have y is equal to negative x? It's an odd exponent, the leading coefficient's negative. What happens as I head left? The y's go up. What happens as I go right? The y's go down. Now let's look at our parabola. Y equals x squared. The exponent is even. The leading coefficient is positive. And so as I head left, y's go up. As x heads right, y's go up. Last one, y equals negative x squared. Exponent is even. Leading coefficient is negative. What happens as x's head left? Y's go down. As x's head right, y's go up. Now, based on this, we'll know everything that we need to know. We just need to know what is the highest degree, that is, what is the degree of the polynomial and what is its coefficient. So whenever you're odd, whatever happened with x to the first is going to be the same. So we see that when I head left, I'm going to go down, right goes up. If left goes up, right goes down because they go in opposite directions. And with even functions, if one end is up, the other end is up. If one end is down, the other end is down. Now, what are we going to do to determine this? First off, you put your polynomial in standard form, and when it's in standard form, the highest degree or exponent is first, down to the lowest degree. And since the highest degree is listed first, the name of its coefficient you learned was the leading coefficient. So I'm going to have the four possibilities. You could be odd and your leading coefficient is positive. You could be even and your leading coefficient is positive. You could be odd and your leading coefficient is negative. You could be even and your leading coefficient is negative. Now, this determines your right-end behavior. Notice left appears before right, but you don't determine your left-end behavior until you've got your right-end behavior. So this right-end behavior says you're heading up or rising, down or falling, down or falling. So notice the positive told me I was heading up, rising. The positive said heading up, rising. The negative said falling, going down, falling, going down. Now, after I know the right-end behavior, how do I determine the other one, the left end, the one that you encounter first? It's based on the degree. If it's odd, you do the opposite. So the first one was odd, so up goes to down. My second one is even, and so up stays up. The third one is odd, so down goes to up. The fourth one is even, so down stays down. So you can see the whole picture. I'll pull it out, but notice I do the first two columns, or I find out what it is. I find the right, and then I back up and I find the left. So you determine the polynomial's degree. You need to know, is it even or odd? You need to know the leading coefficient. Is it positive or negative? Whatever this sign is indicates the right-end behavior. Positive means up, negative means down. The left-end behavior is the opposite if it's odd, and the same if it's even. So let's look at some examples. So I looked at my leading coefficient. It's negative, so I know I'm falling on the right. The degree's even, so I'm going to fall on the left. So the end behavior is falling left, falling right. For the next one, looking at my leading term, The leading coefficient is 5 and positive, so I'm going to rise on the right. The degree is odd, so I need the opposite behavior. I'm going to fall on the left because I just keep thinking of the oblique line. One end rises, the other end falls. So it falls left, rises right. For the next one, I've got this whole thing, but I'm only going to look at the 8x cubed. 8x to the 6th. The leading coefficient is 8, which is positive, so I rise on the right. Now we're going to back up mode. The degree is even, so I'm going to rise on the left also, so both ends rise. For the last example, again, I already have it in standard form, so here's the highest degree term. The leading coefficient is negative, so I'm going to fall on the right. But the degree, which is 5, is odd, so I'm going to do the opposite, rise on the left. Like an oblique line, it's going to be heading down. So I want to find real zeros. I did the first one completely by factoring. This is a review. Real zeros mean no I, guys, and so we know that x squared can't equal a negative. So this is what you would have been taught to do in Algebra 1. What in real life do we do? We go to this next one. You go ahead and factor, and you say, oh, wow, there's no x term. Set them equal to 0. X equals plus or minus the square root of 1, which you know is 1. And x equals this plus or minus the square root of 3, which stays 3. Two more examples this way. The first step is factoring. The second step is doing x squared equals n. The first one would be an I guy, and that's not a real zero, so my only real zeros are plus and minus 2. And for the last one in your notes, that's a plus sign, even though it factors like this, because that's a typing error. And so you just set them both equal to 0, and you have plus and minus 2 and plus and minus 4. Now, we want to, given the zeros, write a polynomial function. And we always do this of least degree unless we're told otherwise. So when I know my zeros are 1, -2, and 3, that means x was 1, x was -2, and x was 3. Undo this step and make it look like a factor. So I do the additive inverse. X minus 1 is 0, x plus 2 is 0, x minus 3 equals 0. Now, since these are all equal to 0, their product will also be equal to 0. So I go ahead and I multiply, and now I have my product equal to 0. This is an equation. I want a function. So what's the difference between an equation and a function? An equation has an f of x, g of h, h of x, j of x, or a y instead of the 0. What's the difference between just a polynomial equation, a polynomial function, and a polynomial is an expression without an equal sign. Just a little review stuff there, folks, for your brains. Now, again, I'm going to give you some expressions that are already factored, and I say find the zeros. And you see -6, 2, and -3. Now, you get hysterical because you say, oh, do I need to write -6 3 times? No, in math, we just write the zeros once. But we can talk about the multiplicity. This guy's multiplicity is 3 because he appears 3 times. His multiplicity is 2 because he appears twice. Multiplicity means how many times do you multiply it, folks. Do not make it a hard word. And the last one appears once. The multiplicities, or the exponents out here, when you add them together, give you the degree of the polynomial. So this is a 6th degree polynomial and even. And for all of these polynomials I've written, the leading coefficient will be 1. So we notice that since they're all positive, the right end will be up, and so will the left end. All of mine somehow managed to turn out to be even. So again, I find the zeros, just 6, 2, and -3. I can discuss how many times they appear, 1, 3, and 4. Add those up, and I know my degree is 8. For the next one, I have -6, -2, and 3. How many times does each appear? 5, 1, and 6. That adds up to 12 for my degree. For my last one, the zeros are 6, -2, and -3. How often does each appear? Once, thrice, and 4 times. The degree is 8. Now, I can ask you to write a polynomial of least degree, given these zeros. I threw this one in as an extra to do a little more discussion. You all freak out when you see x equals 0. Notice it's a monomial, so I'm going to stick it in front. So it was easy enough to do. But now what if I didn't restrict it to least degree? What if I just told you to write the polynomial with these candidates? Notice I can put on all these different multiplicities. Without a restriction, there are an infinite number of possibilities because I have an infinite number of choices, positive exponents to put on here. So this is why they typically tell you least degree. Or they will come over here and say, I want the 0 to appear once, I want 5 to appear twice, and -4 3 times, and then that would give me G. What if they told you I want 5 times, and I want 0 3 times, and I want -4 7 times? That would give me H. What if I told you I wanted 0 4 times, I wanted 5 9 times, but I only wanted -4 twice? That would give me this. So unless they tell you the multiplicity, when you write it, you do least degree.